Welcome to Tech Talk 2005. We're kind of wrapping up our 2004 segment, and so we're moving into the 2005 year next year. So before we do that, if I can get my computer screen up, I'm going to switch it back to my Tech Talk 2005. It's brought to you by the Advanced Technology Research branch in the Office of Curriculum, Instruction, and Student Support, Hawaii State Department of Education. You know, again, we've been getting some comments about what happened to the show. It used to be at 3:30, but now it's at 4 to 5 p.m. on Thursdays. And the replays are still on Saturdays from 11 to 12 p.m. Make sure now Saturdays, please don't call in. Sometimes we have an open line and people call in Saturdays. How come nobody answered? Well, that's because it's a replay. Okay, just kind of a heads up. You know, everybody says, wow, March 1st and 2nd, that's quite a ways off. Actually, it's important that we get the word out. We're having an e-school conference on March 1st and 2nd, 2005 at the Hawaii Convention Center. We'd like you to go to that URL, that atr.k12.hi.us, because this is where you can get information about what's going to be happening at the conference. We're presently looking for vendors. We'll be having registration open pretty soon. If any of the school people would like to present, this is the place to go. So we just like a heads up, because you know, when you think about it, when you come back in January, we're going to have about 2 months before the conference actually happens. So we need your help. Get the word out right now. Okay, we're going to start with the introductions. And Scott, you've been on earlier, kind of giving us an overview of the open source type of program. Tell me, before we get into talking about the program, tell me a little bit about yourself and how you got involved with this open source business.
Kerry, several years ago, while a student at the University of Hawaii, I was very disturbed by a pile of discarded computers under the staircase at the School of Business, and was tired of hearing about our schools having trouble bridging the digital divide and building an economic alternative to tourism. And it was very clear to me that these computers could become a usable asset by our schools to meet or exceed NCLB mandates. And so I founded this nonprofit called HOSEF, the Hawaii Open Source Education Foundation, to promote and sustain the use of open source software and to allow our schools to learn how they can use free software to power older computers and build literacy in our schools.
Okay, great. So are you still going to university for classes and things?
I received my MBA earlier this year, and
Great.
I'm finishing a master's in communication at the University of Hawaii, where I'm also studying the diffusion of innovation with respect to open source software.
Great. Okay, so now we're going to actually get into our agenda items, and if we can quickly look at that. You know, I need a little help with, kind of help me again with a definition of what is this Linux type of software we're talking about. Then we're going to get, I hopefully an update on some of the activities that you're planning for Hawaii. And then we'll actually get into the installation, server, desktop operation, and maybe if you could actually at the end maybe comment a little bit about repair, because I think we talked about that in the last show, but you know, you talked about using some of the discarded computers, and so repair becomes a kind of a different ball game. Rather than calling up for help and buying new parts, buying new computers, you have a different approach to that.
And we have some great things to talk about there.
Okay, why don't we go ahead and start? Let's talk a little bit about, give me a definition. What is this Linux software we're talking about?
Well, Linux is an operating system for your computer. Now, you and I don't care about the operating system. It's the thing that makes the hardware and all the stuff inside the box control what you see in front of you, the software. The best metaphor is a car engine. You don't buy a car for the engine. You buy it for the experience. You buy it for the usability of the interior. Same with computers. So Linux, not unlike Mac or Solaris from Sun or Windows from Microsoft, is just software that controls and operates a computer system. Hence the name operating system. Linux is an operating system, however, that has enabled more and more people to build free and very impressive software applications. So often when we talk and say Linux, we're actually referring to an entire culture of software development often referred to as GNU Linux. And this includes not only free software, but also software that you buy from companies like Mac.
Okay, so again, you know, just for our schools, we have a lot of Windows machines out there. We have a lot of Macintosh, so the OS 10, OS 9, whatever. Now, so does Linux have like numbers, you know, like Windows XP, OS 10? Is there a Linux 1, 2, 3, 4, 5, something like that?
There is. Linux itself, the operating system, is referred to as a kernel. And the kernel is at number 2.6. And of course, it started at 0.1 in the early 90s. And so there is a numerical progression that enables one to track progress with metrics like that.
Okay, now I know we covered a lot about what's going on in our schools in our last show, but can you kind of give me an idea what's going on in Hawaii with HOSEF?
Well, we are working very, very hard, Kerry, to enable our schools to appreciate that Linux and free software is a viable alternative in some cases to other computer platforms and helping our children to meet the new NCLB standards, both in raising math and science literacy. And so what we have been working on for a few years now is donating computer labs to schools that are powered by a centralized server, a server that the school can build itself or can buy from a vendor like a Gemini Tech or a CDS who sells Solaris systems. And we've been going to the schools and saying, look, that computer you used to throw away, that can be powered with Linux and open source software with one central key investment, a central server. So to give you a very good example, at Enchanted Lake Elementary, we recently approached that school, found they had no computers in a particular room, donated 30 discarded machines. The school spent $3,344 to buy a server and a switch, and suddenly 30 discarded computers were functioning workstations, helping children to meet or exceed standards.
Okay, so again, what we're experiencing right now is a lot of schools, you know, have a mix. They have Macintoshes, they have Windows, you know, so they are now able to take advantage of some of the recycled, let's say, computers from businesses, from the community, from other schools, and put them back into the school for what kind of you know, applications do they? Do they have to know Linux to run these machines?
Absolutely not. If you can use a GUI, that's the acronym for Graphical User Interface, then you are fully capable of using Linux. There's no migration, there's no way that the migration is any way a challenge to the end user. If you are capable of using what we call a mouse and a keyboard, then you can use Linux and open source software.
Okay, so you don't need to know all those cryptic commands and codes and things.
You really don't. That's just what you call fear, uncertainty, and doubt. It's what people used to associate with Linux and open source software.
Well, I think that's where the Windows environment came from, too.
Well, right,
we remember DOS,
right,
you know,
DOS.
commands. And so you pretty much say, well, wait a minute, I want to see a picture, and I want to be able to click on things. I want to do word processing, spreadsheets. I want some graphics.
And all those programs are available for free with Linux and with the software that we've been installing for schools. Because what's happened with this thing, this free operating system called Linux, is people have been able to take this engine, if you will, and build cars. We call them distributions of Linux. And they have been able to customize them in such a way that maybe one version or distribution of Linux fits a school's need. Maybe one fits a business need. We promote one called the K12LTSP. It's developed in Oregon in the school districts there. It's been in use for years, and it's powered by a flavor of Linux called Fedora that was actually started here in Hawaii. Anyone who thinks that we can't have some global impact in the software economy, we already have. So people have taken this thing, this version of Linux called Fedora, packaged free programs on top of it. Geometry educational programs, chemistry tutorial programs, physics tutorial programs, programs that help build literacy and algebra, computer programs that help with typing. And something has happened where, because the code is open, when we talk open source, it refers to the way you develop the software. The way companies like Microsoft develop it, using the engine metaphor, is they keep the engine locked. You don't get to look at it, you don't get to see it. And that's a good thing if you don't care about it. However, should you wish to build literacy or learn how to support yourself, this open platform allows you to see the guts and the code of software, and it also enables a paradigm of software distribution whereby it's free. And that's something I really want to show you today, because we talk to people about, okay, this software is free. What do you mean free? Because there is no such thing, and it sounds almost misleading. So we promote that Linux is free to download, and it's free for you to make CDs with that you can then install onto a computer.
Okay, so you don't have to worry about copyright issues then. You're telling
really
you to
don't.
please download it. Okay, I've got your computer up on the screen. You want to go ahead and
Sure.
start? Let's talk about how we get it and start up our, this is the server installation we're talking about now, right?
Exactly. What I am going to show you is how you can go and download this software for free. And the first lesson you're going to get is that the distribution model for open source software is network and server based. And there are things called mirrors that replicate and mirror data. And thanks to the University of Hawaii's ICS department, we are able to provide software. And so by going to the website, hosef.ics.hawaii.edu, don't write it down. Just remember hosef.org. There's a downloads link on our website. And clicking a folder called the K12LTSP, then clicking a folder called current, and then a folder called ISO. And that's the file format for these things that we burn onto CDs. So simply by clicking on ISO, there's several CDs that one can click, and using the very familiar and intuitive Mac operating system, we can save it to disk.
Okay, so you know, you're doing this with a Macintosh laptop?
Sure.
iBook?
Sure. Yeah.
Okay.
Making sure people, because this is so common in the schools, and I'd like for people to see an intuitive way, because chances are we might actually in the schools be downloading the Linux CDs on our Macs. And what will happen is over the next few minutes, this CD will be downloaded to the computer, and I will then be able to burn an image. In the interest of behaving not unlike a cooking show, we'll go to the after effect.
Okay,
Here
so
is a
download.
pre-made CD.
Maybe we should give a caution, because you're downloading information that fits on a CD. If you have an old dial-up connection, this is going to take you a very long time.
That's an excellent
If you're in a
point.
school and you have a decent connection, you know, most of our schools have very good connections, in fact, on Oahu, it'll come down pretty quick. If you're at home on cable modems, DSLs, I think it's not going to take that long.
An hour or less.
Okay.
And if you're in the DOE network, it'll take about 3 minutes for a CD. 10 minutes for all three.
Okay.
And after we get into the installation and we're in kind of this phase where the CD's spinning, I can show us real quick what you do to actually burn the CD, because there'll be a few lulls. So what I'm going to do now is power on this server, which, in moving some things
Okay.
around.
That looks like it's coming up.
Okay, good. We got power. We're going to insert the CD. Improperly, but we'll insert it nonetheless. And what's going to happen is our computer is going to boot from the CD. Now, by default, most computers are set to look for the CD first to boot from. Otherwise, one would go into BIOS and change the boot order. I think in the interest of keeping things simple, we'll just show how we boot the CD. We're introduced to a very familiar and intuitive screen. By hitting enter, we're exposed to some startup stuff. And often when people think Linux and open source, this is what
That's
they
what
think.
they think about.
Right,
Right.
DOS. It's like, oh my gosh.
When I see that, I say, okay, that's very complicated.
That's why we don't use it, is because that's what it is.
Right.
Well, believe me, my friend, it gets better. If you're installing this, I do suggest that you go ahead and choose to check the media. This will do an MD5 sum check and make sure the data is okay. In this case, because I've done that already, it's safe to choose skip. But we would advise, if you're a teacher or you've decided to download this in your school, go ahead and just run through that process. Make sure you didn't download a corrupt image.
Right. Okay, so while we're waiting for that to come up, what about, where did you get that box, that tower? Is that a high-powered $3,000 machine?
That's
or
a
is that
super question. This computer is the story of the Hawaii Open Source Education Foundation. What you see here is a collection of parts from 4 or 5 different entities across the island. Entities who had hardware that they chose to discard, hardware they no longer needed, including the hard drive container that came from a local architectural firm, our CD that came from a discarded pre-Pentium Packard Bell, a tape drive that came from a business that no longer needed it. The case came from someone I consulted for a few years ago. He wanted a new computer and the case wasn't worth throwing out. And the inside has hardware that was purchased by McKinley Adult School in exchange, or what we did is one of our volunteers did a class for teachers, forewent his salary, and then we generated a credit and bought some hardware on the inside of here. And because HOSEF's mission is to collect hardware and to build value and educational opportunities in it, this really tells a story of our volunteer efforts to take what used to be discarded and do something special with it. So with respect to the with the installation, it might be interesting to see the 5 or 6 clicks that I go through to take us through the installing. On the computer screen, I'm going to click Next to finish installing the server here. And a great thing about the distributions of Linux is that they're language friendly. So should I choose to install in Chinese, Japanese, or different European languages, I can right out of the box. In this case, we'll go with what we know and install English. Imagine that. And what will happen very quickly is I'm going to choose to install this software. I'm going to choose to install the Linux terminal server, and I am going to automatically partition my hard drives. Don't let the steps scare you. Stay with the default, click Next, keep going. Same here. Say yes. Don't read too much into it. And again, you can simply click Next, because the configuration for this software, Kerry, is by default set up to work out of the box to get you online and connected to the internet. The one perhaps trick is figuring out where you are.
yeah, you have to click in the middle of the ocean there.
Yeah, and I think I've got it. Yeah, good, good. And then one little configuration step, the root password. In the Mac world, this is an administrator password, Novell Windows administrator. And whether you ever use open source software or not, I encourage you to appreciate how important this next step is. Do not choose your dog's name, your birth date, or something that familiar. I will, for the moment, choose something that is familiar, but remember that something alphanumeric with capital letters and strange characters is the best way to maintain your security.
Will this take a 15-character password?
This will take a 30-digit password.
Okay. Well, I just read somewhere that they said somehow if you have 15 characters, whether they're asterisks, periods, whatever, numbers, letters, it seems like it's very difficult to crack. Not impossible, but very difficult to crack.
Yeah, and the more random your password, the better. But regardless, if you're using your computer in an unsafe environment, or to discuss some of what's in our schools, if you're using computers that haven't been patched for viruses or have been compromised by spyware, it really doesn't matter how good your password is, because everybody's going to read it, because your computer's compromised.
Right? Yeah. Okay, so right now we're going through the process of installing server software on a box that has, what does that box have? It has a hard drive, has a processor, does it have a lot of memory?
This is a high-end server, reasonably speaking. We have a 2 gigahertz CPU. Okay. We have a gigabyte of RAM. We have only a single hard drive, but it's a fast 7200 RPM hard drive.
Okay.
It is pretty much close to the minimum of what you'd want to see. You know, about a gig of memory. You could go as low as a half a gig, but the first thing you're going to do once you install the server is want to connect 4 or 5 clients to it. And so we advise that you start at a minimum of a half a gigabyte of RAM and at least a gigahertz server, and then incrementally add 100 megahertz for the CPU and 64 megs per client. So with those metrics in mind, we have a 2 gigahertz CPU, a gig of RAM, 1 hard drive, and this can easily, as a server, power as many as 10 clients, or what used to be discarded computers. But it's important to touch on something there, because when I talk about discarded computers, it is a little misleading. You had someone from a local vendor on a few weeks ago, and they were talking about the Hewlett-Packard thin client. And this is actually new hardware. Because while we're eager to help schools that are in a position where maybe they don't have the funds, there are times when a school is in a phase where it has funding for technology, doesn't want to use older hardware. And our model here of using Linux on a server does not preclude you from purchasing brand new thin clients from a Hewlett-Packard or from a Sun Microsystems. But what you need regardless is a high-powered server. And while we certainly promote a school to look within its own campus for maybe a machine that's not being used that's fast enough, we're also happy to work with them to order the parts and assemble it. I mentioned the $3,300 that EOLE had spent. But we also try to encourage our schools and local vendors to appreciate that here's real opportunity for vendors to sell hardware and supported hardware to our schools. Because a Hewlett-Packard and a Dell and a Sun sell servers that can run Linux. And so you don't necessarily have to do this in such a grassroots way that the tech coordinator feels threatened by so much free, and there's not a phone number to call.
Okay, so again, you could probably buy this system as a thin client operating Linux, and you can buy it from a vendor. They'll come in, install it, do everything. But the purpose of this is actually to be able to try and use what we already have, some of the existing hardware, and then not spend a lot of money to be able to get a lab up and running, get more students on there so they can get access to the instructional materials. And again, if you have a lot of money, it's very nice to buy new ones, but our schools don't have a lot of money.
And we want the business community to realize that ultimately this software is a great thing for business development. But we also really try to advise our schools on how you can use what you have to keep software dollars on the island and perhaps spread our software resources, or our resources, manage them a little better so that we can perhaps pay teachers a little better. And that's a message that we find resonates well. And so what HOSEF does is we try to show people that you can do this, and then we do things like on Saturdays at the McKinley Community School for Adults. We do free workshops for teachers and recipients of our labs. Because we've learned, Kerry, that it's very easy to walk into a school and give away hardware and pat ourselves on the back and say, that's great, we're wonderful for giving away hardware. But tech coordinators have too much to do. Tech coordinators, in our experience, seem to be spread as thin as possible, and the last thing they need is some new technology or some new system that they have no idea how to support or where to go for help. And so in addition to being a resource for donated hardware, we also do workshops at the McKinley Community School for Adults where we show people how to manage the software and how to install it. And it sounds harder than it is. It amounts to saying, oh my gosh, it's that easy. I can't believe I made such a fuss over it.
Okay. Well, again, I think this is what we're looking for, is supporting our schools, and as we look at tech coordinators, I think we talked about this in an earlier show too, that you have a range. You have some that are very technical, and you have some are very strong in the curriculum instruction background. So, kind of you need I guess you need something to support the various types of coordinators. And you mentioned that there might be some volunteer support from HOSEF.
What HOSEF tries to do is this. We have tried to create the free infrastructure for support. Free again being that should a tech coordinator have some wherewithal and the desire to learn something, we have free resources. They include the hands-on sessions at the McKinley Community School for Adults on Saturdays. They include things like the mirror, the software mirror that we went to download the software that we support. It includes the statement we make to all schools, which is that for the lifetime of your computer lab that we donate to you, we will always provide you replacement thin clients. I mean, we are so flush with them that we are there to say to you, we can replace them. And we are there when we donate. Keep in mind, Kerry, that, and I guess I should maybe emphasize this, we can keep our checkbooks at bay. The way HOSEF operates as a community service to build awareness of Linux, we go to the schools and do not try to profit from this gift. And to enable us to continue to do this, we do say to the school, for the next 6 months, we'll do anything and everything we can for you to support you. But we encourage you to take advantage of our free classes on Saturdays, or to work with volunteers of ours like Ted Kanamori, who, after we donated the computer lab to Enchanted Lake Elementary, Ted would, at the teacher's discretion, do workshops and classes on campus. And we do a good job of recruiting community volunteers who help with community-based support when possible, realizing there are some limits. But we do believe there's enough literacy on the island that we try to be the organizing force so that we can do that.
So in the long run, we're really looking at continuing to get volunteers and retirees and people who have some extra time, like they don't have to be experts, but if they have the, the energy and the willpower to get involved, and they can learn some of this stuff, right?
That's what we would prefer, and we're here to teach them. And we're here to say to those who sell software, the schools do count on you and your expertise and your consultative services. And this is software on which you can continue to support your families, yet add value to the schools by providing a 24/7 phone number to dial. That is not our objective. We would like for them to see it, but we exist to say to schools in need, we can help with your needs. And we intend to continue doing that.
Okay, so how are we doing on the server load? Because I've seen servers take, 4 or 5 hours to load. But I noticed if you said only 2 CDs, and usually that doesn't take that long.
We are actually less than 4 minutes away, Kerry, from having a fully functional graphical user interface that anyone from the Windows or Mac world can operate, that anyone who knows how to work a mouse and a keyboard can navigate. And I like to just make sure people know what I'm talking about. It's a mouse and it's a keyboard. And if you can use these two things, you will see in less than 3 minutes now just how easy it is to take CDs that you can install or that you can download, burn, and install for free, reboot a computer, and have a system that we are trying to say to our schools, and have said in the case of over 500 computer donations, this really can help you.
Okay, last one.
So with no further ado, we move into CD3.
Okay, so again, you got this from the university site. You downloaded those images.
Yes, sir.
And then, is it hard to burn that image onto a CD?
It's not. I mean, Windows software that people are familiar with includes, I think Nero is popular. I don't use Windows. There used to be some other product, but it's burning an ISO. And in Linux, it's extraordinarily easy. There are great graphical user interface tools. And in the Mac world, you do something, and I will tell you.
Okay, yeah, there's a burn, a function that you burst it in. Usually what they do is they just drop that image onto the software, and then it just says, okay, insert CD, right? And then it just burns it. So in other words, you don't have to be very technical.
You do not
to burn a CD either.
And here we're seeing, with a click or two, I will find it because it's a graphical user interface.
And so it's the same way, like some people burn CDs for music, they burn the CDs to back up their files,
That's right.
they burn CDs.
That's right.
So it's the same process.
It
It's
is.
not anything very high level or technical.
And the key word is ISO, because it's that image or that file format that people burn.
Okay, so we're getting very close. 2 minutes now.
We are almost ready for me to show the reboot and
Okay, you know, we're right about midway now. What I'd like to do is we'll take a quick break, then we'll come back and we'll do the reboot, and then we'll, you know, continue on from there, because I want to see the hardware side too. Okay, why don't we go ahead? We're going to take a quick break. Those of you out there, you know what the break looks like. You get some homework assignments. We ask you to go on virtual field trips. We'll be posting a survey on that webpage in a little bit, but for those of you who want more information, you can go to techtalk.hidoe.us. That's a new web address. It's a little shorter than the earlier one we had. The other way is you can email us at techtalk@k12.hi.us. So we'll see you in about 5 minutes. Welcome back. I hope you had a chance to kind of stretch your legs. You know, usually in our cyber recess, what we try to do is we incorporate little different tips and techniques. In fact, we'll be doing some little clips that students have put together on how to do different things with their computers, and looking at how technology supports the instructional process. So what you saw there was a real quick, I think it was a QuickTime clip, and what you can do is you can change the amount of light that goes through, and you can actually see right through the clip as you're playing that. You know, we want to thank Kapiolani Community College for hosting us. You know, every week we have Carl and Lynn and Kenzan, and you know, they're in the background doing all the work, and we want to just acknowledge that without them, you know, we don't get this job done. And especially today, we have two new people that are supporting us, Joy and another Carl, and we want to thank David upstairs for allowing them to come in and help us out. We really appreciate that. You guys are really great here. Okay, why don't we go back? We're going to switch back to our server side. And what is this? This is the finished screen, right?
This is it. During our break, Kerry, the third CD popped out. We are left with this screen. Congratulations, install's complete. Click to reboot. And now the magic of free software will begin.
Okay, but I still see that cryptic
I know it. Don't
code.
be afraid. Don't be. Fear not, my friend. The only thing is when Linux just hasn't hidden all that behind a nice fancy flash screen.
Well, it's funny too because even our OS 10 software has that stuff in the background. There's a Unix core that runs that we don't see all the time. So, you know, if you ever find out, you start seeing that code, it's not a good time to fool around with it.
That's right.
Not unless you know what you're doing.
That's right. That's right. Hands off. So that's our boot screen. And what you'll notice is that the Fedora project will hide this in a second, though, and it will give you a pretty picture to look at.
But every time you boot this up, it'll go to that, like a background sequence, and then it'll switch over to the graphical user interface.
Like it just did.
Okay. But and you don't have to know any code or commands or anything to get that done.
Just like beginning with basically Windows 98, we didn't expect our end users to know about DOS. We don't expect with Linux people to know anything about that tech stuff.
Great.
At all. But not unlike Windows, both have evolved in a similar way. So here what we see is that a new piece of software was identified. And so we just go ahead and click Configure and go through it. Because one of the best things about free software is that not only are all the programs included, Kerry, but also the drivers, printer drivers, hardware drivers. And so an installation can become literally a matter of a 30-minute process. In sharp contrast, a friend has asked me to reinstall Windows XP on her computer, and now that I have taken the time to install the operating system, it's been 30 minutes, I have untold hours of updates to run. Then I need to install my applications. You'll see things are very different here.
Do they have updates like the Windows environment and the Mac environment? They have it online for the Linux.
Software is a work in process. It is never perfect, and no matter what software you're running, you should check weekly for software updates because humans make mistakes and bad humans find them. So a splash screen upon reboot, some basic step-throughs. We're going to agree to a license.
Because if you don't agree, then it just shuts down.
You won't. But you know, we talked about copyrights earlier and how we can use this software for free. There is a copyleft model in open source software, whereby if you take my code and you use it, you are legally obligated to reciprocate your modifications and changes. I helped you, you helped me. So it's the exact opposite. It's, yes, you can use it, but you better give back if you use it. And it's that culture of legally enforced sharing that has created what I'll finish showing you. So I click yes, and I accept such an agreement because we're comfortable with this. And I have not connected to the internet, but by default, we're set up to get our IP address from a DHCP server, like most of the DOE network is set up. So one would be able to, if you've hooked it up, to get your date and time from the network. For now, I'm going to skip that.
Okay.
And I am going to stay with 800 by 600, just so that we can be sure that we continue to be seen on screen here.
Okay.
And I'll click Next. And then we'll add a user. Because keep in mind that in the beginning, we only added an administrator. And so we want to add a user who doesn't have the same privileges as the administrator. And this is part of the successful model of Linux, is that it's designed to protect the system from people making mistakes. A sound card is configured. We don't need the additional CDs. We click Next, and we will be taken for a quick second to that. And then we have a login screen, not unlike what we're used to from the Mac or Windows world. And I created a user named Student, and I type student and then student, and we see that, although we talked a lot over it, about 20-25 minutes of installation time later, we have a graphical user interface that has a word processor called OpenOffice that runs on the Mac, it runs on Linux, it runs on Windows. The file formatting is standards compliant, which is we try to consider that to be important with our education objectives. It should also be important with our vendors. So voila, a word processor that looks not unlike WordPerfect or Microsoft Word. We don't have to go install it. We need to do spreadsheets. Here is the spreadsheet application. It is legal and in fact expected for you to download and install this for free. These groups that put this together encourage your assistance, but let's look at what really matters to our schools. We're talking about how we can go to our schools, help them to use resources they already have, a little of the good old-fashioned noggin, and free software to help our children. And within this menu of edutainment are programs like Atomics. This is a molecular modeling program. You have something, let's start with K-Touch. Many schools go out and buy typing tutorial software. And in doing so, they send money off island and we never see it again. And chances are we pay for things that are easily achieved with software like this. And I could go on, Kerry, and I will do it anytime one of our schools is interested in having me come in and talk to them about what Linux and open source can do. And it would all be great if all we had to do was have lots of fast computers like this, and we would just install free software and life would be great. But we don't have that money all the time. And so I'd like to show you how you can take this server and turn around and power what used to be previously discarded equipment with nothing more than a high-speed internet cable and a fancy network card.
Okay, that's a 10100 card?
Thank you. This is a 10100 network card that is in the server, and I will show you at our demonstration table what's inside of the thin client.
Okay.
Give you a look at the 10100 card and a high-speed cable.
And those things are very inexpensive now, right?
Less than $10 in hardware is going to turn a Pentium 166 into this computer's clone.
Fine. Okay, why don't you go ahead and get set up over there. I'm going to stay over here and I'm going to show some URLs that we'd like the schools to take a look at. Why don't we go ahead, we'll show that screen. And I want to just remind everyone that, you know, these are things that are going on right now in business, in your homes, just everywhere. You know, this spyware, adware, you know, we've got hackers going around, we've got viruses going around. So to protect yourself, this is one of the places that I'd like you to try to take a look at, that www.spybot.info. We also have the www.free-av.com. We have www.ca.com. And NSSB, our Network Support Services branch, has their own site, nssb.k12.hi.us. And we have our own software that was purchased for our schools, as well as I think they just brought in some spyware software that you can download. But this must be done from our school sites. Okay, why don't we go ahead? We're going to switch over to our magic of TV. You came from right here. Now you follow that wire, and Scott is over there.
Thanks, Kerry. So in the server that we installed, there were 2 network cards. And we have attached a basic Cat5 cable to the back of one of those network cards. Our walls are full of these. Schools are very well wired in Hawaii. And then we have plugged this into a simple 10100 switch. To be a little technical, we generally recommend a gigabit NIC and a gigabit switch. But to keep it simple, let's focus on the fact that we have a network card in the server. That cable from the server goes into the switch, and then I take another cable and I bring it into what our schools have plenty of: older Pentium class computers. Pentium class computers that are no longer fast enough to run any programs. However, we have discovered a way. It's terribly inaccurate. We promote a way to use older hardware in this software model with Linux in a terminal server environment. What I am going to show you is that I have before me a computer. The CPU is so slow we don't even have a fan on top of it. And there's no hard drive in here, I promise. But if you want proof, let me just make sure that you see that there are no tricks up my sleeves. There is no hard drive up under here. We have nothing more than a power supply, RAM, and a CPU. The killer component is this $5 piece of hardware, a network interface card, and in particular, that special chip that tells this previously discarded piece of junk, go to the network, hunt down your operating system, and fly, my friend. So allow me to watch you, or allow me to show you what happens when I press the power button. This computer will sync up with the video output, we believe. Then I will show you how it boots off of the server. And let me see if we have I'm not sure if we have a signal from it yet. But what's happening is that this card, I'll work out the video in a second, but little by little this card is drawing its operating system through this cable, through the switch, through this cable, off of the server. And in the interest of showing you just how impressive that can be, I am going to work a little harder to make sure that our video display captures the video output. I believe we have it all plugged up correctly. And give it a nice restart to synchronize with the video signal. So it's almost hard to believe, but the client-server model has been around for quite some time. And I am still thinking that we don't have our video display. We can try a different client. Unless I have just plugged something up incorrectly. The most important thing is at all times be prepared. And so what I will do is show you with a similar machine the boot sequence. Because it's one thing for me to sit here and tell you this is booting off of that server and you can take my word for it. But when it sounds too good to be true, it might be. So you really must see for yourself. So what we will do is take a contingent computer. We did research this prior to starting, and I think that I have just perhaps plugged something in out of sequence. But fear not. This machine can't be as easily disassembled for me to show you that the guts are in fact free of a hard drive, but you can rest assured that I'm not misleading you.
Scott, while that's booting up, are we supposed to see anything special on the server?
We should not. We should just be able to get the video output of the client, though it wouldn't be impossible for me to plug it in over there. But what's remarkable is that the client boots up to a screen not unlike what the server shows earlier with the graphical login. And I'm just really at a loss unless I press the power button on the AV key, and then I think we'll actually have signal now, Kerry. Maybe I should expand my lesson a little further. Sometimes in TV studios
we got something coming
you
up
have
right now.
switches, and they have power buttons also. And so one should remember to press that power button in order to get the picture on live television.
Okay.
So what would be very impressive is for me to start this over and for you to watch what happens. Because we do have video output. Please excuse the slight error. And this computer, that not unlike this is hard drive free, is about to take this computer high-speed cable, pull the operating system through the switch from the server. And it might be a great thing to show that.
Okay, it's coming up right now. You've got that.
Okay.
You've got the cryptic.
Yep. Cryptic
Linux
still.
code. There you go.
But what's remarkable is that this screenshot you have now is actually of this almost piece of junk in front of me. And in just a few more seconds, this, what used to be trash, will have a fully functional graphical user interface that we can log into.
There we go.
And so voila, S-T-U-D-E-N-T, I log in, and I've logged in with the same name, and so the computer is being kind enough to tell me, hey, you're already logged in, but that's okay. And so watch how fast programs open, okay? Because you're not going to be able to go out and get yourself a Pentium class computer with 32 megs of RAM that can open a web browser that fast. And it's impossible to go out and take a Pentium computer and open a word processor that fast. And this is the magic and the amazing thing that we have been promoting for the DOE with thin clients, is that with a centralized server, that if it's a school that maybe has heat issues or maybe vandalism issues, one can take the simple asset of the server, put it in a secure environment, and the only connection you need from that server is a network cable. One can have a lab full of junk, and believe me, this is junk. HOSEF every day intercepts this from the landfills, takes it to places like Honolulu Community College, takes it to places like the Boys and Girls Club or Campbell High School, and we refurbish it, and then we give it to the schools. Thousands of learning opportunities waiting only for a switch, high-speed cable, and a centralized server.
Okay, Scott, we're kind of getting to the end of the show. Why don't you come back over here? You know, this is something that we're promoting in terms of use of the existing equipment. So, you know, we talk to businesses and they talk about having I guess a refresh cycle of 3 years, maybe 5 years at the most. DOE's refresh cycle is a lot longer. A lot of times equipment stays in the school, you know, 5, 10 years. And this might be a way to get a little more mileage out of some of our existing equipment. Okay, so if we can ask one more question about the server. Basically is normally in the a server room, library, computer room, whatever. So it doesn't really need a monitor.
It really doesn't.
It's basically for setup.
That's right.
Once it's set up, then you can kind of put the, can you put the keyboard and the mouse away too?
We try to put the keyboard and mouse kind of away so no one's tempted to even touch it.
Okay, so it just sits there in the closet. And then in the classrooms, you could have these in a computer lab.
Yes, sir.
Or because you said they can be anywhere on campus,
Yes,
they
sir.
could be in 5 different rooms.
They really can, because so many campuses have that fiber backbone, which makes it possible.
So it's again, I guess if you have a 10 megabit network, it run a little slower, but it will run.
It will run.
Okay, if you have a 100 megabit network, then it will be pretty quick in terms of being able to run applications.
Absolutely.
Or whatever.
And we would advise maybe not the 10 megabit, but you can try.
Right. Okay, what about, what happens to the student file? Say they do a word processor and I want to save that file and I want to be able to, you know, come access it tomorrow or maybe get at it from another classroom. Is that available to the students?
Yes. What we have begun to work with people like Peter at Liho Elementary on is many schools have a Mac server that works as a centralized file server, and it's not impossible to have our Linux servers authenticate and centralize user files. So there is the way to integrate with, say, a Mac-based file server, but also the beautiful thing is that students' files stay on the server. So for the tech coordinator, when you have a Linux lab like this, you don't have 30 workstations, 30 hard drives, 30 places for students to lose files. Everything's centralized on the server.
And then it's also, is there a security that can, you know, prevent me from getting access to your files?
Sure, sure. The same, in fact, better security protocols exist within Linux to authenticate. And also, Linux provides the same file serving capabilities as Windows. You can even have a Linux server be your primary domain controller, like we buy from Microsoft now. So sure, great security measures in place.
Okay, and then my last question is, you know, it always comes up, well, what about all these hackers and viruses and spyware and adware and things that I was kind of talking about earlier, because it affects everybody. I mean, the Macintoshes, the Windows, is it the same for the Linux?
It is not the same for Linux. And many people try to say, well, that's because Linux is not as popular, so people don't write for it. 7 out of 10 websites are powered by Linux and open source software. And yet there's scarcely the security violations that exist within the Microsoft or proprietary products. So we find that on the desktop, you just can't install the spyware, and the viruses and Trojan horses just don't have the ability to run because Linux has been designed from the ground up with security in mind. And when you have your code open, there's no cheating or misleading.
Okay, and then the other, I guess, related to that same question, when you set it up, is there a button that you press that says turn off all the unnecessary ports or close? Is there a firewall function in there?
I skipped right through that in the installation step. On the third or fourth step, there was something I said yes to, which firewalled the server except for Secure Shell, which is a trusted protocol.
Great, great.
Right out of the box, Kerry, functional.
Great. You know, those are some of the things that always come up. But, you know, Scott, I want to really thank you. You know, if we can get our screen up again. You know, it's been really great that we've had this kind of volunteer services, and I guess, you know, it's ironic that you talk about Microsoft because our next show is going to be Thursday, January 6, 2005, and Microsoft will be our guest. So
I'll be watching.
We will want to kind of take a look at these. But anyway, thank you for tuning in. Scott, thank you for joining us.
Thank you, Kerry.
We hope everybody has happy holidays, and you know, we'll see you in the new year.